So let's go ahead and talk about half angles and double angles, because just like we can add and subtract angles, we can also multiply them by 2 and divide by 2. So if you guys look at sine of pi over 8, sine of pi over 8, you guys can split this up as pi over 4 times 2. And if you guys notice, that means that you have a little 1/2 being multiplied to it. So reality, this is really just sine of pi over 4 over 2. So this is the half angle of our nice pi over 4. And so what we can do is apply this formula over here, which says that if we have a half angle of sine of pi over 2, we can apply this formula here. It just depends, it says plus or minus depending on what quadrant we're in. So sine of pi over 8 is actually in the first quadrant. So because that's in the first quadrant, we know that sine is positive. Sine is actually positive in the first quadrant. So we can say that this is going to be equal to positive the square root of 1 minus cosine of alpha. Our alpha is this number on the top. So it's pi over 4. So we have cosine of pi over 4 all over 2. And let's just simplify this. So we want to evaluate this. We know that cosine of cosine of pi over 4 is just the square root of 2 over 2. So we can write that instead, and that's all over 2. And since we have a denominator, we can simplify this a bit. So we can multiply everything by 2 to get rid of the denominator. So if we multiply everything by 2, that cancels out, and we're left with the square root of 2 minus the square root of 2 all over 4. But whenever you have a square root over the whole thing, you can take the square root of both the numerator and denominator. So if we take the square root of the numerator, we're just left with 2 minus the square root of 2. But if you take the square root of 4, that's actually just 2. So you get this as your final result. And it's positive, remember, because sine is positive in the first quadrant. Let's look at another example. Let's say we were given that sine of alpha is just our angle, is equal to negative 5 over 9, with alpha being between 3 pi over 2 and 2 pi. This part right here essentially means that this is in quadrant 3 quadrant 4, because we have 3 pi over 2 and 2 pi, so that's in quadrant 4. It says, give the exact answer for the following. So we want to look for sine of alpha over 2, cosine of alpha over 2, and tangent of alpha over 2, and so on. So since our angle is between 3 pi over 2, that's 270 degrees, and 2 pi, remember, is just 360. That means that our angle, alpha over 2, if we cut that in half, that's going to end up in quadrant 2. Because anything from 270 to 360 degrees, if you split that in half, that ends up in quadrant 2. But let's first deal with this information here. So since our triangle is in quadrant 4, remember that all triangles look either in this sort of bow tie form. So since it's in quadrant 4, our angle is going to look something like this. And with this being our right angle. So we can label. So since we have our sine being equal to negative 5 over 9, we know that since it's sine is opposite over hypotenuse. So our opposite side of this angle here is going to be negative 5. And then our hypotenuse is 9. So we have labeled all of our information. And so now all we have to do is just figure out what this missing side is on top. We can do that by using the Pythagorean theorem, because we know that the Pythagorean theorem can be used on any right triangle with a missing side. So we have a squared plus negative 5 squared is equal to 9 squared, because the Pythagorean theorem is a squared plus b squared equals c squared. So this is just going to be a squared plus 25 is equal to 81. Solving for this, we would get what our a is. So we would have a squared is equal to 81 minus 25. That's 56. So our a, if we take the square root of both sides to get rid of the squared, we have that a is equal to the square root of 56. So that is this side on the x-axis. So now we know what this piece of information is. That means that we can figure out what cosine is. So cosine of alpha, remember that this angle here is our alpha. This is our alpha because that's the angle that we're looking at. So our cosine of alpha is, cosine is adjacent over hypotenuse, so that's the square root of 56 over 9. And the reason why I looked for cosine was because if you look at all these formulas, they either have sine of alpha or cosine of alpha. So we needed to know that information in order to get the answers that we needed. So let's go ahead and plug everything in. Now that we have our information, we know that sine, by looking at this formula here, sine is just the square root of 1 minus cosine of alpha. We said cosine was the square root of 56 all over 9, and that's going to be all over 2. And now we have to determine whether it's positive or negative. And that, since sine is in the second quadrant, you guys can remember that in the second quadrant, we have all students try cheating. So in the second quadrant, since our angle is in the second quadrant, sine is positive. Now, let's look at our cosine. So for cosine, we're looking at this angle now. So for cosine, we have in the second quadrant, remember all these angles are in the second quadrant. In the second quadrant, cosine is negative. So it's going to be negative square root of 1 plus cosine of alpha. We said that that was the square root of 56 over 9 all over 2. So this is our answer for that. For tangent, we're also going to want to look at a different one. So cosine, tangent, even though the tangent has all these 3 equations, you can use any one that you like, any one that you please. So I'm going to use this middle equation just because it seems a little more pleasable. So we know that sine of alpha was originally negative 5 over 9, and that's going to be rewritten all over 1 plus the cosine of alpha. Cosine of alpha, we said, is the square root of 56 all over 9. So these are our answers, and that's it. So just like we can find the half angles, we can also find the double angles. And since we are dealing with the same problem, we can just go ahead and plug everything in. So we already know what cosine of alpha and cosine of alpha are. And since we're looking for the double angle of sine, we can use this formula here. So this sine of 2 alpha is going to be equal to 2 times sine alpha. Our sine alpha, remember, was negative 5 over 9. And times cosine of alpha, that was the square root of 59 over 9. So now, all we have to do is simplify this. 56. So remember that when we multiply across, so this would be negative 10 square root of 56 all over 81. And from here, we can actually simplify the square root of 56. I didn't do this earlier, but you can split it up by writing 56, and that you can break up by multiplying 4 times 14. And so this simplifies to 2 square root of 14. So if we plug it in, it's equal to negative 10 times 2 square root of 14 all over 81. And so our final answer would be negative 20 square root of 14 all over 81. And so that's what we would get for sine of 2 alpha. For cosine, we actually have 3 different formulas that we can use. But I'm going to do it with this first formula, just because it seems a little easier. So we know that we can plug everything in. Cosine, as we said, was the square root of 56 over 9. So that's going to be squared. Minus sine. Sine was negative 5 over 9 squared. And that was just from the formula. We would just plug everything in. So remember, again, when we square something, we have to square both numerator and denominator. So the square cancels out. So we're left with 56 over 9 squared is 81 minus 25 over 81. And since they have the same denominator, we can subtract them. So this is just equal to 56 minus 25. That's 31 over 81. So this is our final answer for that. For tangent, we actually have to find what tangent is. So if we look at our triangle, tangent of alpha is actually just opposite over adjacent. So our opposite side is negative 5 over the square root of 56. So if we plug this all in, we would get 2 times negative 5 over the square root of 56 all over 1 minus negative 5 over the square root of 56 squared. So if we square this, we would get 2 times negative 5, that's just negative 10. So that's negative 10 over the square root of 56 all over 1 minus negative 5 squared is 25 over 56 because the square root cancels out the square. So this is what our answer would be. If you guys like this video, make sure to give it a thumbs up and subscribe for the next videos.